The next topic, this is section 9.1. We will look at trigonometric identities in a little more detail. We have already seen a few trigonometric identities. The main ones have been sine square t plus cosine square t equals 1. And then tan t is equal to sine t over cosine t, and cotangent t is cosine t over sine t. And then we also saw that how secant t is the reciprocal of cosine, and cosecant t is the reciprocal of sine t. And then finally, cotangent is equal to 1 over tan t. It's the reciprocal of tangent. And then we saw the even odd properties of the trigonometric functions, which basically tells us how the value of the function changes, or if it changes when you change the sign of the angle. So we saw that the sine function is an odd function, which means sine of negative t is equal to the negative of sine t. And the same is true for tangent. Tangent also is an odd function, and so when you change the sign of the angle, the whole function changes sign. Cosine, however, is what's called an even function, and that means when you change the sign of the angle, the value of the function remains unchanged. Cosine of negative t is the same as cosine of t. In this section, we are going to look at many more identities, and we'll show that these identities are true based on these identities I have written down here. And we will also be doing basically a lot of algebraic manipulation of trigonometric expressions to come up with different ways of saying the same thing. So let's look at problem number 5, in which we are given an expression sine x times cosine x times secant x. And we are asked to simplify this as much as possible. So using the fact that cosine and secant are reciprocals of each other, you can write this as sine x cosine x. And then instead of secant x, which is just 1 over cosine, so you can bring that cosine in the denominator and then cancel the cosines. That leaves you with sine x. So that's your answer. In other words, the expression sine x cosine x times secant x simplifies to simply sine x. In the next problem, we have another expression, cotangent t plus tangent t over secant of negative t. And we have to simplify this again. One technique that we use in simplifying or manipulating trigonometric expressions is to convert everything into sine and cosine. So if I do that here, cotangent becomes cosine t over sine t, and tangent becomes sine t over cosine t. In the denominator, we can actually do two things. One is write secant as the reciprocal of cosine. Now it would be cosine of negative t, but since cosine is an even function, cosine of negative t is the same as cosine of t. So I can simply drop that negative sign. And then I'm going to bring this 1 over cosine t up in the numerator by taking its reciprocal. So in other words, dividing something by 1 over cosine t is the same as multiplying it by cosine t. So this becomes cosine t over sine t plus sine t over cosine t times cosine t. And next, I can distribute the cosine t. So if I bring that, or let me actually just go ahead and add the two terms in the parentheses using a common denominator of sine t cosine t. The first term, the denominator was already sine t, so it needed a factor of cosine t. So you multiply top and bottom by cosine t, which makes this cosine squared t over sine t cosine t. In the second term, you would need to multiply top and bottom by sine t to get that denominator. So sine t times sine t is sine square t. And then this is being multiplied by cosine t. Two things here. One, this cosine t will cancel the cosine t in the denominator. And secondly, cosine square t plus sine square t being 1, I can simply write this as 1 over sine t. And sine is the reciprocal of cosecant, so this is just cosecant t. In other words, that expression that we started out with, cotangent t plus tangent t over secant of negative t, is simply equal to cosecant t. Let's look at another similar problem. This is number 13. And in this case, the expression we are given is 1 plus tan square theta over cosecant square theta plus sine square theta plus 1 over secant square theta. And again, we have to simplify this. So let me, again, convert everything to sine and cosine. So this becomes 1 plus tan is sine over cosine. So tan square is sine square theta over cosine square theta. Cosecant is the reciprocal of sine. So that becomes 1 over sine square theta plus sine square theta. And then secant is the reciprocal of cosine, so that's just 1 over secant square theta is the same as cosine square theta. And then notice that the last two terms add up to a 1 again. And if I convert this division in the first term into a multiplication, by taking the reciprocal of 1 over sine squared theta, it becomes 1 plus sine squared theta over cosine squared theta times sine squared theta. Plus, we have a 1 from sine squared theta plus cosine squared theta. And then let me add the two terms in parentheses using a common denominator of cosine squared theta. So the first term would become cosine squared theta over cosine squared theta. So that's just cosine squared theta in the numerator. In the second term, we already have a cosine squared theta in the denominator, so the numerator just remains sine squared theta. And times sine squared theta, and then plus 1. Cosine squared theta plus sine squared theta again is 1. So 1 over cosine squared theta times sine squared theta. And then we have a plus 1. So I can rewrite the first term as sine squared theta over cosine squared theta. Plus 1. Just bring the sine squared theta here with the 1. And then I'm going to add these again using a common denominator of cosine squared theta. The first numerator remains sine squared theta because the denominator is already cosine squared. The second numerator would become cosine squared theta. So you're multiplying that 1 by cosine squared theta and dividing by cosine squared theta. So, and then once again, the numerator is simply 1 sine squared theta over cosine squared theta. So this becomes 1 over cosine squared theta, which is secant squared theta. So that's what this long, complicated expression basically simplifies to a secant squared theta. In the next set of problems, we're going to use the same techniques, but with a slightly different end in mind. So like in number 16, you're given the expression tan x plus cotan x over cosecant x. And we have to rearrange, manipulate, rewrite this expression in such a way that our end result has an expression containing only cosine x as a trigonometric function. We don't want any other trigonometric functions in the end. So we're going to use the same strategy. Let me first convert everything to sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. And cosecant is 1 over sine. And let me combine the two terms in the numerator and bring this 1 over sine x up as a product with a multiplication with sine x. So this becomes using cosine x, sine x as a denominator. In the first numerator, which was sine x, now needs to be multiplied with this sine x in the denominator here, so that it becomes sine square x. In the second term, we already have a sine x in the denominator, so what's missing is cosine. So you multiply top and bottom by cosine, and that becomes cosine square x. And this needs to be multiplied with sine x. Two things here. The numerator is again 1, sine square x plus cosine square x. And this factor of sine x in the denominator can cancel the sine x up here. And that just leaves us with a cosine x. And that's what we wanted to do, express the given expression in terms of something using only the cosine function. Let's look at problem number 20. The expression is 1 over 1 minus cosine x minus cosine x over 1 plus cosine x. And we have to rearrange this, expression so that our final answer contains no other trigonometric function than cosecant. Let me start by subtracting the second term from the first using a common denominator of 1 minus cosine x times 1 plus cosine x. To get that denominator in the first term, you'll have to multiply top and bottom by 1 plus cosine x. So 1 times 1 plus cosine x. In the second term, to get that denominator, you have to multiply top and bottom by 1 minus cosine x. So that's cosine x times 1 minus cosine x. And then we distribute the 1 and the cosine x in the numerator. So 1 times 1 plus cosine x is just 1 plus cosine x. And when you distribute the negative cosine x times 1 is just minus cosine x. And negative cosine x times negative cosine x is positive cosine square x. Now, in the denominator, we have 1 minus cosine x times 1 plus cosine x. So using a result from algebra, something like, if you have x minus 2 times x plus 2, if you FOIL it and simplify, it basically ends up as x squared minus 4. So using that result in the denominator here, 1 minus cosine x times 1 plus cosine x is 1 minus cosine square x. And in the numerator, you can cancel the 2 cosine x's. And so that gives you, you're left with 1 plus cosine square x over 1 minus cosine square x. Now, cosecant, remember, is the reciprocal of sine. So instead of the cosine squares, we want to have sines in these expressions. So the way we convert a cosine square into a sine square is, again, using the identity that sine square x plus cosine square x is equal to 1. And so cosine, if you subtract sine square x from both sides, cosine square x is 1 minus sine square x. So I'm going to use that result in the denominator here. 1 plus 1 minus sine square x. Similarly, in this identity sine square x plus cosine square x equals 1, if you subtract cosine square x from both sides, that leaves you with sine square x equals 1 minus cosine square x. And that's what we have in the denominator. So 1 minus cosine square x is just sine square x. And that gives us 2 minus sine square x over sine square x. I can split this term into two terms. So 2 over sine square x minus sine square x over sine square x. Now, we want our final answer to have cosecant, and 2 over sine square x is in fact 2 times cosecant squared x, because cosecant and sine are reciprocals of each other. Minus 1. Sine squared x over sine squared x is 1. So that's our answer. Let's do one last such problem. This is number 24. We have to rewrite tan x so that the only trigonometric function remains is the secant function. So once again, I'm going to convert the tan into sine and cosine. So tan is sine over cosine. Now remember, secant is the reciprocal of cosine. So we are okay with having a cosine here, but we need to convert the sine into cosine somehow. Sine x over cosine x is the same as sine x times secant x. Now, how do we convert sine x into cosine x? Basically using the same property that we had earlier here. So sine squared x is 1 minus cosine squared x. So if you take the square root of both sides, you get sine x equals, every number has two square roots, a positive and a negative, so plus or minus square root of 1 minus cosine square x. So we can replace that sine x by plus or minus square root of 1 minus cosine square x. So this is plus or minus square root of 1 minus cosine square x times the secant x. Now that secant x is outside the radical. We can bring it inside the radical by making it secant square. So this becomes plus or minus square root of 1 times secant square x, which is just secant square x. And then minus cosine square x times secant square x. Again, cosine and secant are reciprocals, so that product is just 1. And this is what we wanted, our result to have just secant, and that's what we have. So that's your answer. Or tangent x is the same as plus or minus square root of secant square x minus 1. The next type of problems is one where you're given an identity, and we have to show, we have to prove, we have to verify that that identity is in fact true. So in problem 29, the identity that's given to us is cosine x minus cosine cube x is equal to cosine x times sine square x. Now the strategy is to start on one of the two sides. And you want to start with a more complicated side, because then you have room to simplify things. In this case, I'm going to start on the left side of the equation and then show that it's equal to the right side of the equation. So what we have on the left side, or LS, is cosine x minus cosine cube x. So we have a common factor of cosine there. I'm going to factor out the cosine x, and that leaves me with 1 minus cosine square x. That's what we have on the left side. And 1 minus cosine square x, as we have seen, is just sine square x. So the left side is simply cosine x times sine square x, and which is what we wanted to show, that the left side equals. So this is equal to the right side. And that completes our proof, our verification that indeed this identity is true. Let's look at number 31, in which we have to show that 1 plus sine square x over cosine square x equals 1 over cosine square x plus sine square x over cosine square x. And that in turn is equal to 1 plus 2 tan square x. So I'm going to start on the left side again. First show that that's equal to what we have in the middle, and then show that what we have in the middle is equal to what we have on the right. The first part is pretty straightforward. All you have to do is split that left side into two terms. So that's 1 over cosine square x plus sine square x over cosine square x. And that's equal to this middle side. So next we have to show that that's equal to the right side, 1 plus 2 tan square x. So I'm going to add these two terms. and this is equal to, I'm going to think of that 1 as sine square x plus cosine square x, the one that we have here. So if I write that as sine square x plus cosine square x, then this becomes and the two denominators are the same, so I can combine them. And now in the numerator, I can combine the two sine square x's. Plus cosine square x over cosine square x. And then if I split this into two terms, I have 2 sine square x over cosine square x plus 1. And 2 and sine square x over cosine square x is tan square x. So this becomes 2 tan square x plus 1. And that is what, if you rearrange the two terms, this is 1 plus 2 tan square x. And that is what the right side is. So that completes your proof. Let's look at problem number 33. We have to show that cosine square x minus tan square x equals 2 minus sine square x minus secant square x. So let's start on the left side and change the tan squared into sine over cosine. And convert the cosine square into 1 minus sine square x. And convert the sine square x in the numerator into 1 minus cosine square x. Now, if I split that last term into two terms, it becomes 1 minus sine square x minus 1 over cosine square x. The last term will be positive because we have two negatives here. So plus cosine square x over cosine square x. And then this becomes I'm going to keep the 1 minus sine square x. And then 1 over cosine square x is secant square x. And cosine square x over cosine square x is 1. And then I can add the two ones and becomes 2 minus sine square x minus secant square x. And that is the right side. Let's look at number 34, where we have to show that 1 over 1 plus cosine x minus 1 over 1 minus cosine negative x is equal to negative 2 cotangent x cosecant x. So let's start on the left side and combine the two terms there. At the same time, noticing that cosine being an even function, cosine of negative x is the same as cosine x. So we can just drop that negative sign there using a common denominator of 1 plus cosine x times 1 minus cosine x. So the first numerator would be 1 times 1 minus cosine x, which is just 1 minus cosine x. And the second numerator would be 1 plus cosine x. Now, because of the negative sign, both of the terms will become negative. So that's what it ends up as. Now we can cancel the two ones and combine the two cosine x's. And the denominator is just 1 minus cosine square x. 1 plus cosine x times 1 minus cosine x is 1 minus cosine square x. And 1 minus cosine square x is sine square x. So if you, now notice what we want here is negative 2, which we already have, and then we want a cotangent. So how do you get a cotangent out of this situation? You think of sine square as being sine x times sine x. And then if you look at this ratio, cosine x over sine x, that's just cotangent x. And then the sine x in the denominator it's like 1 over sine x, so that's just cosecant x. So that gives us the right side that we wanted. So that's your proof. Now, in this case, the problem is phrased slightly differently. It's asking if indeed the left side is equal to the right side. And we found that it is equal to the right side. So this identity that or the equation that we started out with is in fact true. The last two problems are also similar. You're given an equation and you have to show that, well, you have to determine if it's a true statement or false. So this is number 35. Cosecant square x times 1 plus sine square x. Is it or is it not equal to cotangent square x? So we start on the left side and write the cosecant as the reciprocal of sine. So this becomes 1 plus sine squared x, which we already have, and that cosecant square ends up in the denominator as sine squared x. Now, we are trying to see if this is equal to cotangent square x or not. Cotangent, remember, is cosine over sine. So we already have the sine squared part in the denominator, which we wanted. So if the numerator was cosine squared, then the identity would be true. In order for that numerator to be cosine square, you would need this positive sign to be a negative sign, because then we could say 1 minus sine square x is cosine square x, but it's not. So this equation is not true. It's a false equation. It would be true if instead of a plus sign here, you had a minus sign, but in this case, it's not. One last problem is number 42. We have to show that secant theta plus tan theta over cotan theta plus cosine theta. We have to figure out if this is equal to secant squared theta or not. So let's start on the left side and convert everything to sine and cosine. Secant is 1 over cosine. Tan is sine over cosine. Cotan is cosine over sine. And cosine is just cosine. Then we, in the numerator, the two denominators are cosine, so we can keep that and just add the numerators. And I'm going to bring the denominator here up as, you take its reciprocal. And in this denominator, using a common denominator of sine theta, this will become sine theta over cosine theta plus cosine theta sine theta. So I've done two things here. I've first combined these two using a common denominator of sine theta. So the first numerator remains cosine theta. The second one becomes sine theta cosine theta. And then when you take the reciprocal of this, you get that. Sorry, this is theta. So that's 1 plus sine theta over cosine theta times, I'm going to factor out the cosine theta here. Which leaves us with a 1 plus sine theta in parentheses. And then you can cancel this factor of 1 plus sine theta with the 1 plus sine theta there. So that makes this simply sine theta and over cosine squared theta, because you have two factors of cosine. And the question was, is this equal to secant squared or not? Well, 1 over cosine squared theta is secant squared theta, but we have this additional sine theta here. So this equation is also false. That's the end of this section.